All right, grade 10s, our goal is to solve linear systems in this unit, which means that we're looking for a point of intersection of two lines. Or we're looking for the answer that solves both equations. So I'm going to look for a place today where these two lines meet each other, and I will find an answer that works for both line 1 and line 2. So for the first system, I have line number 1 is in slope y-intercept form, and I'm pretty fast at graphing that. So I'm going to graph line number 1 by using a y-intercept of -2, and I have a slope of invisible 1 over 1. So I'm going to go up 1 over 1, up 1 over 1 to be able to draw that line. So line number 1 looks like that. So I'm going to label it y equals x subtract 2. The second line is also in slope y-intercept form. Y equals -x plus 4. So let me just change that. There we go. It has a y-intercept of 4. So there's my starting point. And it has a slope of -1 over 1. So there's my y-intercept. My slope is down 1 over 1. Down 1 over 1. So we just need to be careful about our slopes, and we will have our two lines. If you need to pause this video, you certainly can. And so if I draw carefully, and if you think it's okay to trust your eyeballs, I'm just saying, we might have a better strategy tomorrow. We have our two lines, and I am looking for the solution that works for both of them. And that is the point of intersection, which I can see right here. So therefore, here I am, lazy. The point of intersection is, according to my eyes, 3, 1. That is the solution to both of those lines. Here's a second system where I have two different lines, and I know that they're lines because they have x's and y's and numbers and nothing crazier than that. But both of them are in kind of this hybrid of slope y-intercept form and general form. So I just have to figure out the best method for graphing. So line number 1, when I look at that, I think, you know what, honestly, that would be really quick to write in slope y-intercept form. So for line number 1, I would subtract 3x from both sides, and then I would graph it with my y-intercept and my slope. There's nothing wrong with that. So my slope technically is -3 over 1, so I'm going to go down 3 over 1 when I draw it. So line number 1 is going to start at a y-intercept of 5. It's going to go down 3 over 1, down 3 over 1, and I have my line. Making sure I've lined that up okay. Hard to see on this thing. There we go. Okay. For my second line, I'm not so sure I want to rearrange that to a slope y-intercept form. Yesterday I learned about x and y intercepts. So for that second line, I'm going to find my two intercepts, I think, maybe a little bit more quickly. So I am going to first of all find the x-intercept, and that is where my y value is 0. If I substitute y equals 0, I am left with -x equals -15, or x is 15. This is where I have the advantage. I can move my grid a little bit. My y-intercept is where my x value is 0. So I'm going to substitute x equals 0 into the equation, and I would be left with 3y equals negative 15 because that first term is 0. Dividing both sides by 3, I would have a y-intercept of negative 5. Let's see how I can do to fit this. If I have a y-intercept of negative 5, 1, 2, 3, 4, 5. It's the trick about getting the x-intercept in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Watch me cheat. I don't care where you're from, that's awesome. There. Ta-da! And my x-intercept is 15, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There we go. So my line, now that I've established 2 points, is there. So it appears graphically that my point of intersection, and I should write it as a point, is 3, comma, negative 4. So if that's true, and I were to substitute the point 3, negative 4 into both of the equations, I would find that it works. In other words, if I put 3 in for x and negative 4 in for y, I should end up with 5 for the first equation. And if I put 3 in for x and negative 4 in for y, I should get negative 15 for the second equation. And I do. That point works in both. Let's look at the next system. X plus 2y equals 6, and 3x negative 3y equals negative 9. So for the first line, I have decided I'm going to graph that using x and y intercepts. So my x-intercept is where my y value is 0. If I substitute y equals 0 into that line, that guy is 0. So I am left with x equals 6. So I have an x-intercept of 6. Secondly, my y-intercept for that line is where x is 0. And if I put a 0 in for x, this is 0. I am left with 2y equals 6. Divide both sides by 2, y equals 3. I have a y-intercept of 3. So you can see why we worked at that yesterday. It makes graphing these lines pretty fast. All right, the second line, that is line number 1. Line number 2. I think I'm going to do the same thing and find my x and y intercepts. My x-intercept for line number 2 is where y is 0. I would be left with, substitute y equals 0, I would be left with 3x equals negative 9. Divide both sides by 3, I would have negative 3. So negative 3, 0 for this one. My y-intercept is where my x value is 0. I need to go back up to line number 2. When my x value is 0, this guy is 0. I am left with negative 3y equals negative 9, so my y value is 3, 0.03. Oh my goodness, they both share the same y-intercept. So that's easy enough to see. My point of intersection is 0, 3. All right, one last example. I want to find the solution to or the point of intersection of the two lines. The first line is 3x plus 2y equals 6. I've decided not to rearrange that to y equals mx plus b. I like finding my intercepts. So for line number 1, I'm going to find my x and y intercept. For my x-intercept, my y value is 0. So I'm going to have a point that looks like that. I'm going to substitute y equals 0. And when I do that, the first term is going to be, the second term is going to be equal to 0. So I'm not even going to write it. I'm just going to say I'm left with then 3x equals 6. So at that point, my x value would be 2. My x-intercept is 2. For my y-intercept, for that line, my x value is 0. If you put a 0 in for x, this disappears, and I'm left with 2y equals 6, or y equals 3. There is my line, or my first line. And 3x plus 2y equals 6. For the second line, I am also going to find my x and y intercepts. I am going to find my y-intercept, first of all, which is where x is 0. I would be left with negative 2y equals 10 if I substitute an x value of 0, which would give me a y value of negative 5 if I divided both sides by negative 2. So my y-intercept for line number 2 is a y-intercept of negative 5. My x-intercept for line number 2 is where I have a y value of 0. If I put a 0 in for y, I have a 0 for the second term. I am left with x equals 10. So my x-intercept is 10, 6, 7, 8, 9, 10, which is right there. Joining those 2 points, I have my line. My point of intersection, which is looking a little off on mine, which is why you want to graph ever so carefully. Therefore, the point of intersection is 3, 4, comma. And you also want to look at it really carefully. 4, negative 3. You have some textbook work to work on today, and you'll need some graph paper.